Hello students, this is Mr. Yao. Today we are going to start a new unit, Unit 6, which is about circles. And we're going to have 4 lessons to learn all sorts of basics about circles. Today's lesson is number 1. We're going to learn about lines with circles. First, let's see the official definition for circle. Circle is the set of all points in a plane that are equal distant from a given point. And that given point is called the center of the circle. So here's basically what this means. If you have a point, you have a certain distance, you can kind of go around, and everywhere you go is going to be that same distance. And if you keep doing that all around, you are going to eventually create a circle. That's kind of what this means. And this center, of course, is called this point is called the center of the circle. And we typically use this notation. A circle with center P is called circle P, and we will typically write it as a circle. This little symbol, we seriously just draw a small circle with a center. Then use the letter that's the center of the circle to represent. All circles are similar, of course, because they're all circles. You can choose to expand it and make it bigger, make it smaller, but they're all still going to be circles. Circles have radius and diameter. Radius is a segment whose end points are the center and any point on the circle. So it's saying for a radius, you got to start from the center, is kind of ending on a point, ending with a point that's on the circle. Radii, that is the plural form of radius. Then there's diameter. Diameter is twice of the radius, so that's why d equals to 2r. Next, chord. Chord is a segment whose end points are on the circle. Doesn't matter where the end points are, as long as the 2 end points are on the circle, it is a chord. So here's the little question for you to think about. Is diameter a chord? The answer is yes, and diameter is in fact the longest chord in a circle. Because, the endpoints are actually on the circle. It's just going through the center, that's all. So it's still a chord. And here's some formulas that you have learned before. Circumference is 2 pi r, or pi d, and area is pi r squared. Let's move on. Lines with a circle. First, a secant line. A secant line is a line that intersects a circle in 2 points. So this is a secant line. You see it's going through the circle with 2 points of intersection. Next, a tangent line. Tangent line could be a line or a ray or a segment. A line looks like this. Goes on forever on both ends without ending. A ray has a starting point and is going to one direction. A segment doesn't actually go infinitely anywhere. It's just a little segment that has 2 endpoints. So tangent line, tangent ray, or tangent segment that intersects a circle in exactly 1 point. So here's the 1 point, this point B. That's the tangent that's intersecting with. The tangent line is, you see the notation, we use actually 2 arrows, double arrows, to indicate it's a line AB, and we also have the tangent line segment AB, which you see there's no arrows drawing. We also don't need to draw the endpoints, it's just a little bar. And then we also have the tangent ray, BA. And you can see this end there's like no arrow, and on the other end there's 1 arrow. So that's a ray. And these are all altogether tangents. With tangents, of course, there's something special about this point. This point is called the point of tangency. It's the point where the tangent line intersects with the circle. Common tangent is a line or a ray or a segment that is tangent to 2 circles. So for example, we have 2 circles. This tangent line right here is like touching the both circles at 1 point. That's called a common tangent. And we'll see more in examples. Now it's time for us to use these vocab and identify. Example 1. Use the best vocabulary to describe the following. Justify your answer. I'm not going to ask you to actually write down all the reasons, but we do kind of need to understand it, so you need to think about it. First, AC. Well, it's a line segment, and C is the center, A is on the circle. That's seriously the definition of a radius. Radius is a little line segment that has endpoints, whereas the center and the point on the circle. Next, AB, that's going through the center. Two endpoints are on the circle. That's gotta be the diameter. Next, DE. It's array because there's only one arrow in the notation and it's touching the circle at point B. So DE is going to be more specifically a tangent ray. AE is going through the circle intersecting at point A and point G. So going through the circle intersecting with 2 points, that is going to be a secant line. Then we have AG, which no arrow on the top is a line segment. So clearly 2 endpoints are actually on the circle. That is going to be a chord. F is asking to name a tangent segment. We can use DE again. There are several different options. DE is a segment that's actually touching at B, or you could do DB. And all of these letters, you can actually flip them around. You can also do BE. Any of these would be a tangent segment. That's example 1. Next, example 2, more practice in identifying. CD. CD is touching the circle at point D. And it's a little line segment because there's no arrow on the top. So we are going to write it as a tangent segment. The reason, again, is because there are 2 points. D is actually on the circle, and C is just outside the circle, and is only touching at 1 point. Next, KG. 2 endpoints on the circle, and it's going through the center, which is J. That is going to be the diameter. Next, EF. You see the notation only had 1 arrow, so it's clearly going to be a ray. And that means in this case, if you look at EF, starting from E, going to F, it's only touching the circle at 1 point. So that's going to be a tangent ray. Next, BK. BK, as you can see in the notation, has 2 arrows, so that's going to be a line. And in that case, let's have a look. B is right here, K is right here. It's touching circle A at B, touching circle J at K. So that means it's tangent to both circles, but it's not just tangent to each circle, it's actually to both. That means they share it. So the most precise name for it is going to be a common tangent. Next, HG. It is going through the circle at point H and G, so that is going to be a secant. And secant is just a line. CE. For CE is a little bit special. See, C is right here, E is right here, and if you go through that whole thing, change a different color. If you go through that, it's going to touch at D and touch at E on both circles. So there's still a common tangent, which is this one is a common tangent line, but for F is actually a common tangent segment. Okay, these are more specific names. And G, name a tangent segment. Well, CE is an example, or there's a lot more. CD, DE, CF, EF, or DF. There's also the C, K over here. These are all going to be some tangent segments. Okay, that's example 2. Next, example 3. How many common tangents do the circles have? Again, common tangents means a line that's touching a circle at 1 point, but is actually touching both circles at 1 point. So for A, here's a common tangent because it's touching at 1 point. You can pause here and try to see if you can figure these out now that you have seen an example. Hopefully you have thought through by now, and let's have a look. Here's another one. But it has more than just these 2. I can also go through the middle, touching each circle at 1 point, and also this direction, here and here. There we go. So it actually has 4 common tangents. For B, here's 1, here's another one, and even though the middle is kind of like together, it's not done, there is still a line because they are just touching. This line also just need to go through that same point that the two circles are touching. So there are 3 common tangents. For C, well, this time you can't do anything in the middle, so just the 2 tangent lines outside. So 2 common tangents. That's number C. Moving on, example 4. Now we're going to work with circumference and area. Hopefully you do remember these, because these are some things you have learned before. So circumference, we use letter C to represent, which is pi r. So we're going to do pi times 10.2. On your calculator, you do have the pi button. It is right above the little caret. The little caret on the top, there's a pi. So you're going to put a second, then the little caret, and that should give you 32.0. It's asking you to round to the nearest 10. Don't forget a unit, inch. Area, pi r squared. So it's going to be 10.2 squared. So that is going to be pi times 10.2 squared, which is going to be 326.9 inch squared. Number 5. C could also be, I just realized I actually did the previous question wrong. For circumference, you also need to multiply by a 2. So that is multiplied by another 2. That would actually give you 64.1. There we go. Now, number 5. If you're given the diameter, you don't have to divide by 2 to find the radius, because circumference is also pi d. So this time is actually pi times the 10.2, which is 32.0 inches. Area, in this case, I do need to find my radius, because for area, you gotta use the radius. There is no formula for the diameter. You will need to divide it by 2. So it's going to be pi times 5.1 squared. And that is going to give you 81.7 inch squared. That's example 5. Number 6 and 7, you are given the area or the circumference. Is actually to solve the r, we need to divide both sides by the pi, and that is gone. So r squared equals 490.9 over pi. Here's one suggestion. When you deal with these kind of questions, please try not to find an answer for each step. Keep the part, keep the format, and then so I can type the whole thing into the calculator, which is square root of 490.9 divided by a pi. And that is going to give us 12.5 meter. And now to find the circumference, 2 pi r will be 2 pi times the 12.5. And that is going to give us 78.5, don't forget the unit, meter. Example 7. Circumference is, well, it's asking to find diameter, so we better use that formula. Circumference is pi d, so it's going to be 124.41. Means d is 124.41 divided by, that means we do need to actually find the radius. The radius is going to be 19.8 yard, and the area in that case, pi r squared, is pi times 19.8 squared, and that is going to be find the answer, square it times pi, that is going to be 1.7 yard squared. That's example 7. Next, example 8 and 9. These are kind of some interesting questions. Just to mention it, this time it's asking use exact value, no rounding. Let's actually talk about that in the previous example real quick. If the question is asking you to just calculate out, but there's no need to round to change it in decimal, you are just going to keep it as a pi. So in that case, if you look at this shaded area, it's basically the bigger circle minus the smaller circle. So it's pi times r squared minus pi times 6 squared. So when there's no rounding, instead of calculating out with decimal, we're going to keep the pi. That's 64 pi minus 36 pi, which is 28 pi. That is how we keep an exact answer. Number 9 is asking to find the perimeter and the area. If you, well, I'll actually give you a bit of time to think through. And now we can have a look. If I draw this line, it may help you, because you may notice we can just put this inside right here. So it's actually a semicircle that we're calculating the area for. So it's pi times 74 squared and times a 1/2. Let's keep it as just what it is instead of calculating out the decimal. So that is going to give us 2738 pi. Next, for the circumference. Circumference is a little bit special. First, you do have this portion, which is a semicircle of this 74 as the radius. So let's calculate that. That is going to be pi times r. Because it's not 2 pi r, it's a semicircle, so we just need to half it. And that is going to be 74 pi. We're not done. We also have this part right here. Let me change a different color. We also have this portion right here. But in case you didn't notice, that part is basically this full circle with 74 as the diameter. That's what it is. And you're trying to calculate the circumference for that. So that time we can do pi d. And d in this case is going to be the 74. So altogether we have 74 pi and another 74 pi, which is 148 pi. Don't forget a unit, meter, and this is meter squared. That is example 9. That is everything for 6.1a. Thank you.